Okay. Should be live. That is good. Am I clipping at the top? Just a little. We go E. I'm gonna start my stream avatars. I'm actually not doing my starting soon screen today. You might have noticed. That is because I'm late. I'm also forgetting my headphones. I need to put those on. Alright now, methinks. Because if something happens, I don't want it going through the microphone. Connected to Pop Flash. Yes, indeed. Okay. Then, oh, there's Sharky right away. We're launching stream avatars right now. Then we can get into some programming. I actually probably want this over here. Don't I? Screen will be back in a second as soon as stream avatars does its thingamering. Then, let's see. So I was using this, right? The C++ OpenGL tutorial series. Right? But this is I don't think you guys are very interested in me watching tutorials the entire stream. Oh, I forgot to do Duolingo. I can do that really quick. Oh, 50 squats from Grace. Hi, Grace. Always good to see you. We can do those after Duolingo. I've got to get 30 XP. Wait, hang on. It might need more. That is 12 over 9, huh? Means I'd probably need 2, which means 2 perfect lessons. That means we're definitely going to the katakana section. Yo. Oh, that volume's very low. Yo. You're literally dead right now? Oh my. Well, I hope that it's not that bad. Yo. Okay, that's volume's better. Meh. Maybe that volume's a bit too much. COVID and a migraine. Yo. That is awful. I hope you feel better ASAP. Yo. Oh. Oh. アメリカアメリカ飯読む年時 what am I forgetting right now? I'll explain what I have so far once I finish Duolingo on the squats. And then I will open the OpenGL tutorial. Not this video, which I've been using. But instead other things. Iro. Iro. Oh. Zero. Do. Hang on. Ze. Do. Kiyo. Shime. Roku. Toshi. That doesn't happen often. Toki. Mexico. Mexico. Kiyo. Toge. Meshi. Roku. Yeah. Memo. Let's see. Memo. Oh, memo, not other thing. Oh, darn. Darn. That ruins it being a perfect lesson. That's annoying. I was going too fast. Who warned me about this? Oh. It still counted as a perfect lesson. How fortunate for me. Gas. Bean. Gear. That's... Toge. No. Anago. Negi. Negi. Geru. Toge. Ragu. Gorilla. Gake. Gigu. Sage. Gori. Glass. B, ba,
라,
bu. 싸게
사게,
안 하고
안하고,
꼬리라
꼬리라,
기야
기야,
나무
기야,
구미
그라게,
구라게 가게 기구 기고 꼬리라 안 하고. There we go. That is 2 quests. I like you too, Sharky. Alright, and then we go over here. We switch our striking mode. Woo! Work for me. Aha! There we go. Alright, 50. I gotta go quick because I wanna get to coding and programming. I am not certain what the difference between programming and coding is. I'm gonna be honest. I prefer saying programming, but I hear everyone else saying coding. I just prefer programming. I don't know. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Oh, coding is when you flatline. That's very funny. Page of Moss. Yeah, I've seen you before. I forgot though. 16. We're doing some squats because Grace redeemed them. That's one of my redeems you see. 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. I don't know how I found your stream, but I like the vibes, and now OpenGL should be interesting. Yes, so if you want to learn OpenGL yourself, I definitely recommend the tutorial series I've been following, which is this one by Michael Greco. Oh, you guys can't see it yet. I'll show you in a second. I'm not going to be watching the videos on stream just because it's very boring and I'd be referencing them a lot. Instead, I'm going to... So the Michael Greco tutorial series is awesome and it takes you through step by step. But it basically just takes from the OpenGL website to make the videos and puts them in a very presentable way. I'm just going to go straight to the website so you guys don't have to watch me watch the video. I know WebGL, which I understand has a similar API. Maybe. I don't know much. 41, 42, 43, 44, 45, 46, 47, 48, 49, 50. Okay. There we go. Now we can get to programming. Fine. I'm excited, I'm gonna be honest. I don't know how much people like programming, but I certainly like it. Here. This is the one I was talking about. Michael Greco. Very, very awesome. This is the first stream I've done, but I've been programming for a couple years, so I kind of know what I'm doing. Not really anything specific though, just vague knowledge and several projects that I've never finished. But this is the first time I've streamed it. This also, as you can see, I'm on tutorial number 11, isn't the first, this isn't the beginning of the project. The Twitch dev community is cool. Yeah, I watch Pirate Software sometimes. They're shorts on YouTube. And I'm in their Discord. And my dad isn't a streamer at all, but he works in programming stuff. So that's cool. But here, yeah, basically this, if I run it, I forgot what my shortcut for running it is. It renders Obama, and you can move it around. That's because of this guy. He chose the picture of Obama. So that's why it's Obama. But yeah, that's what we've got so far. Obama. Exactly. You understand. And it's a very interesting process because you've got to Obama GL. Yeah, you've got to define all the things and do all the things. All this does that. Yeah. We're gonna... They got their macros there. I was most of the way through this. It's gonna take me a second to remember what I was up to. I know what the end goal is, right? And I should actually... I should, when I get the chance, make a game design document. Because I've heard that's been recommended for when you're trying to do the things. Hang on. So if you go to Learn OpenGL, it'll teach you how to do the things. So if I go back to getting started, why are you learning OpenGL? Here I should definitely be copying Pirate Software here. If I open up Krita, and I get out my drawing tablet. Actually, no, I don't even need. Well, yeah, I prefer my drawing tablet for this. So basically, the biggest reason is because I'm a little silly. Right? Where is Krita? Oh, it's over here. If I go like this, and this. So basically, as soon as I get this open, settings, show Docker is off, new file. We'll just put it to like 500 by 500. Yes? Okay. We'll put this... I don't even know where to put this. We'll put it there for now. So basically, I want to make a video game. I'm so silly. I didn't actually need this open. I just wanted it open. I'm gonna close it. I want to make a video game, and I looked at Godot, and I looked at Unity, and I didn't really think about Unreal Engine. And none of those seemed like they do what I wanted to do. And I also just really wanted the experience, and so I'm trying to make a game engine. I know it's a bad idea. I've considered that. I know why I'm doing it this way. It's because I want to very make it... Blarg. I don't know. I just think it's good experience to learn how engines work. Unity is everywhere. So is Godot these days, actually. Like, for example, Backpack Battles over here is Godot. Your Only Move Hustle is Godot. So, two games I really like are Godot. Where were we? Shaders, textures, transformations, I think? I mean, making an engine is fun to you to make an engine. The journey is the destination. Yeah, I get that. It's just that, you know, making an engine is only part of the destination, you know? I want to learn how to do it. Because it's not that making an engine itself is fun, it's that I don't know how to do it and I want to know how to do it. That's the main philosophy behind it. Where were we? In practice, GLM. So this, hang on. Okay, so we did that. Very tricky to figure out exactly. Let's see. I know I said I wasn't going to use this, but I actually don't know where he is. So, let's see. Because this is just the coordinate systems. Looking for... I see. Well, turns out I don't know what I'm doing. Who would have seen this coming, right? That's not the one I want to have open. That's also not the one I wanted. So, let's see. Because they're working on
So A
inputs.
should translate it by a negative 0.1 in the x direction, and
Let's see, we should have all those things. Yeah, negative 0.1. 0.1, yeah. Correct.
D should translate it by a
Let's see. Because basically, no matter what I try and program, I'm going to be referencing a tutorial of some kind. It's just a matter of, like, how much I'm willing to have you guys watch it with me, you know? Because it's not a reaction stream or anything like that. I just don't know what I'm doing, and this is one of the best tutorials there is. So it's very tricky.
in the y direction.
I think I'm gonna have to let it play.
Oh, we finished the fucking.
Because the degree to which I don't know what I'm doing is such that I am basically copying this tutorial, you know? Yeah.
That was actually a short 3-hour version that had ever do this. Okay, so you see how. Jesus.
And you can tell it's exactly the same because I have it exactly the same, you know? And I use WASD to move them around. And it's Obama. It's the same picture and everything.
Just look at how fast. See, when he eats that ice cream, he just. It's almost like he gains a fuck ton of energy.
Yeah.
Just look at that. It's amazing.
Let's see.
Now let's do this with the. Let's do this with the joystick.
Yeah. So they want to program in the joystick. How is it
we're gonna say
done?
Float LX is equal to
Play at 1.5 speed.
main j.axes state.
Oh, but your bomb is squished? That's because the coordinates is based on your screen size. So when I have the screen like this, it's like that. But if I do this, it goes like that. And then if I go like... So yeah, it's based on the size of the window. If I go like this, it's normal-ish. Basically, yeah, it depends on the size of the window. I can probably find exactly where it decides that. Let me see. Tisk. I mean, it's not exactly something it decides normally, or rather regularly. Here. So basically, these positions and stuff are relative to the screen. So, well, kind of. This is saying where you place the vertexes, positions. Yeah. So it's like, yeah. It's based on the screen size. I don't know why I keep stumbling over that. But yeah. So they were going to go and they were gonna... I've forgotten... Oh, there it is. Nice. Wait, hang on. We don't want that one commented out. There we go. So they were about to go and they were about to say... main j dot... Oh, float. Right. I'm very sorry if you guys were hoping for something more professional. I don't know what I'm doing out here. Yeah, so they did this after. Main j dot axes state. Yes. That is correct. Wait, no. Not correct. That's an uppercase J. I should have been able to guess that by the fact that it's supposed to be that one. Same thing. And I also have some arguments to pass in.
So GLFW, joystick.
Right, the
Axes,
joystick,
left stick
axes.
X.
Oh, that's what LX means. Okay. Then I'm trying to speed through this a little bit because, like I said, I don't want you guys watching the tutorial the whole time. GLFW. Joystick. Left stick X. Alright, that is correct, isn't it? Left stick X. Wait, hang on, he's doing another thing?
Or just like that, just call the method.
Okay, thought so. So if that's the case, then he's probably going to need all of them. Right? 2, 3, 4. Then we want the right stick. Because I'm assuming both of those exist in the GLFW thing. Then we'll do LY. And we'll do RX. We'll do RY. And then we will see if that's correct or not.
For LY, but make sure it's negative because on the joystick the y-axis is inverted, so main j.axis.
Okay, so it's inverted there. No problem. We'll go bing and we'll go. Hang on. LR is not how that's supposed to be. That's supposed to be RY. And RY probably is also inverted. No problem, no problem.
GLW joystick axes, left stick Y.
Mm-hmm.
So you're going to notice something that if you're not touching it, it's actually going to move. The reason why is because
that's because there's a dead zone.
It's since it's
in most games.
In the input.
Room for error.
Can change. So typically.
I shouldn't be watching this in 480p. I'm sorry. That's partially my fault. If I full screen this, it'll be easier for you guys to see. Then if I go like this, then I can switch between them easily without having to defull screen.
Something called a dead zone. So if
yeah, dead zone I just mentioned. I'm so smart. I was right. So
of LX
the one thing though, if people hop in suddenly, I don't want them to think that this is my code here. My code's over there. Oh wait, hang on. They haven't done the thing. They haven't done right stick, so I'm gonna pretend. Well, I mean it makes sense because this is for movement, right? So we probably don't need the right stick right now. So they said that's an if statement, and I can guess where they're going. If std abs of x it's greater than 0 point something, because we don't actually know, right? Then let's see. I'm gonna see if I can guess what he's gonna do here, right? Because it would be sure neat if I could be mostly correct. This is the x-axis, so it'd be well, let's see. If the absolute value is bigger than a thing. Okay, so I guess I can't guess.
0.5.
0.5, he says.
Then we'll do some movement. So mouse transform is equal to
mouse transform.
Transform.
Oh, I was right. Transform.
Translate.
I did say translate, right? I did. Transform. Vec 3.
Divided by 10.0 or just 10. In the y and z direction.
There you go. That's it. That makes sense. Alex divided by 10. 0.0. And then 0.0. And those do need to be floats. And that should be enough. And then... Oh, and they did say 5 there. Alrighty, right. Then after that, I mean, it only makes sense that they'd go the same exact thing with ly. Relax. By the way, Page of Moths, if you're still there, I'm curious. Do you know who I should be talking to about because you mentioned the where'd you say it? The Twitch dev community is cool. I'm curious about where you think I should be talking to people about Twitch dev things. Because I'm curious how, like, standards, you know? Because I'm sure it's a relatively new category. I did Tan's form. But I'm curious to see, like, who would know what I'm doing wrong. I did LX there as well. That is incorrect. Alright. Then, I don't actually have a controller plugged in. But I don't know if it would work just yet anyway. I don't think we've...
And then similarly for the y-axis of if standard form is equal to
Uh-huh.
the expression ly divided by 10.
Hang on. I just realized my mistake. These two need to swap places. So we're gonna go like this and like that. Just so.
10 in the y direction and 0.0 in the z direction.
Mm-hmm.
Alright, so let me plug in my joystick right here.
Oh, they're just plugging theirs in right away, huh? Let's see if this one works. This is the one I use for Elden Ring, so I know that the controller itself works. It's just got a really long wire for no reason. I'm not sure. I mostly find devs on Twitch through raids or by searching for specific tags related to things I'm interested in Blender and Unity. If you stream dev long enough, people will just find you. That does remind me that I did leave my tags on stream. There we go. I did leave my tags up from Thursday's Guilty Gear, so it still had the fighting game content tag, which isn't quite correct. Alright, let's see about plugging in my controller. But yeah, I guess I'll just have to keep streaming it, because I do indeed enjoy programming. It's something I do a lot. And hey, that works right away, huh? Cool. Awesome. We're technically speaking, I could program an entire video game already in OpenGL. Because we have a way to render images. The one thing we don't have is, like, bounding boxes that I would need in order to detect collisions and stuff. So but we have a lot of what we need already, you know? It's too bad I'm not making a 2D platformer, or else that'd be everything. It's good to know multiple methods of key input. I'm wrapping up my controller. It takes a second. Let's see.
Oh, and make sure you comment out the keyboard input for the movement if you don't want to combine the two. So I just
back in college, you made us write Minesweeper and Tetris in C++ rendered on the terminal. How interesting. So here, let me... So tilde.town is something I technically am, but mostly was part of. Minesweeper was a challenge, I imagine. So I forgot my password, basically, for getting into this. But, back when I was able to get in... Oh, hang on. This was what my page looked like. I programmed this. I just made a quick little script that made these posts and stuff. And I'm gonna hopefully get back in as soon as they get back to me, but there's only like 1 or 2 people in charge of it. But it's just a cool little thing. But basically in there somebody's made a Tetris game that you can play. So that's fun. In the terminal, of course. I've heard this is part of the small web movement. Yeah, I feel like that's the kind of thing that's gonna still exist after Twitter and Threads and Blue Sky. After all the big social media things, things like that are still gonna keep going. So that's why I want to be there. It's also just super awesome and cool. So everyone should be there. They've got their own chat and stuff. So it'll outlast Discord too, and Twitch, and yeah, it's gonna last. I promise. It's been around since 2014 anyway. If that doesn't tell you how long it's been going. Did this not get...
Let's run this. So now you see that it says wireless controller is detected. It is present, rather. I'm going to move the stick to the left, and then move it to the left.
Heard something on Discord. Hang on. We're over here. Stream ping, we saw that already. We're over here? No, we're here. No, we're here.
To the left. And I'm now moving it like semi, and as I cross that 0.5 point, it then moves it.
Yeah.
And decrease the dead zone. Let's see what would happen if I just removed the transform. Or the dead zone.
Yeah. I don't need to bother with that. At least not now. So the difficult thing for me is that my goal with making an engine is some more control over the way things are rendered. Because one of my big complaints with modern games, especially big ones, is that they don't prioritize like file size or anything like that. And I know it's not the best idea to focus on that, and I'm not going to right away, but eventually I'm going to be making it, at least somewhat small. And it's not going to be the smallest game, but it's going to be this smallish file size, hopefully. Smallish file size, decently easy to run on various kinds of computer. Those are my kinds of goals, which is why I want my own engine, so I can control that kind of thing easier.
And LY, just so you can see what I'm talking about. So I'm not touching this, but the values are very small. But for some, in the x-axis actually, that's pretty big. Negative 0.02. So let's say if we treat our dead zone.
I don't know what I keep distracting myself.
Let's see what happens. It's gonna be moving. I'm not even touching. The remote is on. So we can decrease that. 0.5 is a little bit much. So 0.05. You can do this with trial and error. Different remotes, see what happens. So I'm not touching it, and then I touch it, and it does it. Pretty cool.
Yep.
Actually, let's do something cool here. Let's determine if let's try and zoom in here. So let's say float the trigger axis. So
Oh, I know what he's about to do. Hang on. I'm gonna once again try and guess what he's about to do. Let's see. Because the trigger is another axis. Hang on, what have I typed wrong here? I don't think I've done anything wrong. There we are. Barg. Axes, left trigger. Just as I suspected. Good thing I stopped and checked. Every time that you can water it, my pants. Anyone remember VeggieTales? Most people remember VeggieTales. It's iconic. Anyways, if std abs trigger greater than 0.5, we're just going to give the same kind of dead zone, even though we probably don't need to as much. Translate form VLM whoops back 3 then 0.0f 0.0f trigger over 10, and I want that space there as well. Alright, and I did just put my controller away, which was a little silly of me, but I am confident that this will move it towards the camera. Alright, and he mentioned a zoom, which is why this is my assumption. Yeah. I'm hearing stuff on Discord again. Hopefully it's not important. It would be a pain if it was important. Anyhow, let's see. We move it, and then... Oh. I thought it was my Discord and I checked it. Yeah, I should just mute it, actually. It's just that I like knowing when people are talking to me, but during streams it's a little unhelpful. So it seems like my thing here has not worked, and my assumption is that here. My assumption here is that I've kind of forgotten how to do the output command. Should be up here somewhere though. Okay, so it's exactly as I thought it was. So I didn't forget anything. So I'm actually the smartest ever. I can close that. Save. So now we should be able to see, unless it needs to be a string. Nope. Okay. How odd. It should be outputting trigger, but you'll see that it says left trigger there. However, doesn't work. So this leads me to conclude that I'm wrong, but not in the way you'd think. So first off, his controller mappings are different than my controller mappings. A little bit, I think. Because if I go and see where these are defined, yeah. I wrote my own here, because these are the ones he said, but these are the ones that actually is on mine, right? And so if I look for where trigger is, it's actually not there. I don't think I got to that part. But that's okay. We're just gonna switch back. Where is it? Where is it? Here. So we're gonna see what he's got going on.
RT is equal to main J dot
RT.
GLW joystick axes
trigger. Exactly as I thought.
And then we'll have a dead zone against if standard.
Oh,
RT,
interesting.
Transform is equal to GLM scale.
Oh, scale. That's it. So I was moving mine in the Z direction, because that's kind of what I expected. But I don't think we've actually... So you'll see going 3D is down there. I don't think my camera can actually detect that at the moment. So I'm going to go Control Z. I'm going to move this to... Let's see. Yeah. I'm going to switch this to a scale. And I don't think it's a vector 3.
Vector 3.
Oh, it is.
The Z direction. So RT divided by 10, RT divided by 10, and 0.0f. And
okay, interesting. So the scale is a different thing altogether. And I mean, it makes sense. And I'm just gonna... Oh. Now when we do this... Oh, how interesting. Maybe it needs to be 0.05. Let's see what he does.
And the same thing for the left trigger.
Same for left trigger.
LT is equal to main J dot axis state. GLW
Yeah, okay. We'll set that in a second. I just want to see.
Yeah, because we want to scale up, not down. And then we'll say trans.
Okay, well I can just throw in the 1 plus. No problem. Whoops, don't want.
Transform for the left trigger, we'll say 1 minus LT divided by 10. Alright, now let's
Yeah.
this. Oh,
that should...
that dead zone needs to be a lot bigger. Let me print out these values actually. So standard cout, or actually, I think this goes from -1 to 1 if I'm not mistaken. So RT and LT.
So... Hang on. Oh, so it did work? I changed literally nothing and it now works. You know what I think? I think I actually just didn't save it before is what happened. Can get really close on that ice cream there, huh? What's very interesting to note is that I'm not using the trigger. Yeah, I'm not using the trigger. Left trigger here has become the x-axis on my... I should make a note of that over here. Uh-huh. Left trigger. Whoops. We'll just say left trigger became right stick X. Because things are never normal for me. Don't know why you'd expect that. Oh, some head pats for me. Thank you very much, Sharky. Enjoy those. Why do I do? There we are. Head pats ahoy. So, you know what I can probably... Hang on. So I've defined these. I can... So what I should be doing is actually just, like, renaming these. Right? I very much should just rename these to make them the proper variable. And I will, eventually. But that is not my That is not my... Why am I thinking of that word then? Present. That's prerogative, though. Is this not a word? Something to think about for later. It's not my priority. It's a different word. I know that priority is a different word, but don't worry about it.
Print out the values and see what they are each frame.
Here we go.
Okay. Yeah, that makes... Alright, so maybe what we want to do is scale it from -1 to 1 to... Or just change the range, rather. So we'll say RT is equal to this, divided by 2, plus 0.5f. And then if RT is greater than 0.5, then it's just that. And then we'll do the same thing here. So we're just translating it from a range of -1 to 1 to 0 to 0 to 1. And you can remove the absolute value because it's always going to be positive. So now if I run this, you see it's just 0, 0. And this, there's no dead zone. But you can't have a dead zone. Oh, fuck me. He's so... Oh, I guess, yeah. Oh my god. Oh.
Yeah, I don't know if he's going to say anything else important in this one.
Yes, that got inverted for some reason. Jesus Christ. Alright, that's enough of that. Yes, that got inverted for some reason. Oh, you know why? Because I think it's the scaling is done first and then transform. That might be why, but I don't know why that would have an effect. Oh shit, he's small. He's coming.
Alright. It does seem like it's going to be all from him. Hang on.
That's weird. I don't know. But we can also integrate the key input here. So we'll say if keyword is for the close, we'll say that, and then or. One sec. Let me just log in. My other screen went to sleep. There we go. Okay. or main j.get or .button state, and we'll pass in glw joystick button, and we'll say circle or button right.
Boing. We can easily do that. What were they? Says button right, so I'll just do button right, you know? Which happens to be Y for me, which is not on the right. Button right. There we go, and we can test that. If I run this and I press Y. Okay, so that hasn't worked. Did I not save it? How very odd. Did I do something wrong? Maybe it needs to be defined.
And it goes nice.
Huh.
Pop-up less. That is the end of the episode.
Alright. Quite strange. Button state. Button right. Should be one of them at least. Let's see about just saying 2 perhaps. One of these should be making it close. See about that one, huh? Huh. Very odd. Very, very odd indeed. Well, I'm not gonna lose sleep over it. I'll worry about it when it's a problem.
Today we're going to be switching it up a bit with the music. We have a new soundtrack, the Shadow of the Colossus.
Also, you guys, like, check this guy out if you're curious about learning this, because this is the best way to learn this, I feel like. You know? Like, the best.
It's a very good, or a very calming soundtrack. Overlooked a lot of times. I recently found it, so it's pretty nice. Alright, so let's just jump into it, I guess. Today we're going to be returning to OpenGL, and we'll be actually moving from our 2D environment to a 3D environment.
That's what I want.
How to actually transform coordinates so that we can do such a thing. And then we will also we'll also be creating a little bit of a primitive camera as of now, just with movement but no rotation. That'll be next video, I think. That's what I planned. But
let's see. Camera, yeah.
To the code. This should. Alright, it's looking good.
You'll also notice that he's using Visual Studio Code, or just Visual Studio actually, and I'm using Qt Creator. It's because Visual Studio doesn't have a Linux version, and that's really annoying, Microsoft.
Okay.
It's an industry standard.
A couple files here, and for now, well, the first thing we're gonna do is
But Qt Creator has been great so far. And I use Visual Studio Code for... There's Visual Studio Code for Linux, but not Visual Studio. It's ridiculous. Anyways, Qt Creator is a good one. I like it. It's been easy to use and customizable.
So far, we've only the XY plane where z is equal to 0, so that just denotes a plane. D equals 0.
Yeah.
And that would be your typical 2D XY plane. That's what you graph.
Sure is.
Plus beyond, and all that stuff. But now we're going to be adding the third dimension to it.
Oh, this one doesn't have chapters. That's too bad.
So there are
Q.
differences in the description of the video, and I actually forgot to open the link up, but in the description there should be a link to the new vertices. Yeah.
There'd be 8 vertices, which means 24 coordinates total.
So just take these vertices.
Oh, right, plus the 2 there. 1, 2, 3, 4, 5, 6.
And replace the vertices that we have right now and the indices for that matter, because we won't be using those. So we're going to be going back to just using a VAO today. And what you'll notice is there's
Okay. That is the wrong file. So here, we can also scroll here to go through different open ones, which is kind of neat. They want me to get rid of all my very nice vertices over here. That is just fine. I will survive. And they said they had them in here. Vertex data. And it's from Learn OpenGL, just like I mentioned. They're just, you know, praising the tutorial that learnopengl.com has in a very, very nice way. Bink. And if we are, so the EBO probably doesn't, let's see. EBO. That's the only thing that changes, actually. So, I'll just kind of comment that out.
indices for that matter, because we won't be using those. So we're going to be going back to just using a VAO today. And what you'll notice is there's also
Is that 2 yet?
Things are not 8 entries per row, so we're only going to be looking at position and texture coordinates here. So position and texture coordinates.
Okay, I'll put those in that comment in too. Because, you know, comments aren't helpful. I'm not so good at putting in comments. My dad was helping me with some code the other day, because my other project is a web app that I've been working on. Within, you know, Python with Flask, and also some JavaScript, obviously, because you need to talk to it and have it update. It's going to be a very cool thing when I finish. I'm working on figuring out where I should host it, because I accidentally went over my limit with ngrok. So, need a little bit of a more permanent thing for testing and stuff. And I kind of don't want to spend, like, even $4 a month, which isn't much. But I don't really want to spend much money on it, because I can't guarantee it'll make me money, you know? My little web app, even though it'd be super awesome to have a redeem that I animated myself, made the web app for myself. Oh, more head pats, but from Violet this time. Hello, Violet. You love to have the head pats. Or at least I do. I don't know about y'all. Head pats are quite nice. What was I up to? I was following the tutorial.
Alright, so that's the vertices. Now we can get rid of the EBO once again, because we are just simply going to be removing we're just going to be iterating through it by, we'll just be going vertex by vertex. We don't want to have any overlapping. And the reason why is because the texture coordinates are not the same on each face that overlaps with a single vertex. So if we look at a cube here, the texture coordinate on, say, the top left here is not going to be the same on the red face as on the yellow face and on the blue face. So it's going to be different. So therefore we need to have we can just repeat the vertices just for simplicity. There are different ways to implement this. You could create 2 different buffer objects, 2 different attributes actually to do that. But for now we're just going to look at it.
Okay, so they say we're getting rid of the EBO. I forgot what EBO stands for. I'm assuming it stands for Eternal Bomb Object.
Like this. So then
Let's see.
EBO, just completely delete it. Delete the linking of the EBO, and then
yeah.
we also want to get rid of the color attribute, because we don't have it, so we just have the position and the texture coordinates. So get rid of the color attribute, the second one, and then
Really color coordinates. Okay. Boink boink.
update the stride to 5, because once again we only have a 3D vector, and then
That's true, it is 5. I feel so bad about making y'all watch me go through these tutorials, but it's also the thing I want to be working on, so.
That's in 2D vector. And then if you want, you can update the index of the texture coordinate attribute to just be
Uh-huh.
1. So GL vertex attrib pointer should read 1 for the first parameter, and then enable vertex attrib array.
I was not paying attention there. Hang on.
1, and then update the stride to 5, because once again we only have a 3D.
Stride is 5, yeah.
And then if you want, you can update the index of the texture coordinate attribute to just be 1. So GL vertex attrib.
Says if I want, and I kinda do want. Did you do the other number too? He did.
Attrib pointer should read 1 for the first parameter, and then enable vertex attrib array should have an 1 as well.
Yep.
And then the last thing we want to do is the offset for the texture coordinate should only be 3 now.
That is correct. It should only be 3. I know what he's talking about, I promise. That's actually, like, genuinely, I'm pretty happy that I do understand what he's talking about. At least somewhat, you know? I would be in big trouble if I was just copying it word for word without any understanding of what it was talking about. I'm very happy that I understand. I mean, I haven't taken a math class on matrices, but I understand them well enough. I think I watched an extra video on it when he came across matrices to begin with. And on my first computer science course, we did go over matrices a little bit. Not a whole lot, but it came up in passing because we were talking about quantum computers and how the probabilities and stuff work for their things.
You can update the drawing method, so instead of saying GL draw elements, we just want to go ahead and say GL draw arrays. So GL draw arrays, and we're going to have GL triangle, 0, and then 30.
So it's no longer GL draw. Where did I put that? I have to relearn transformation matrices every time I have to use them. Yeah, the only one I really remember is that the identity matrix is the one with just ones. Yeah. Because that's easy to remember. And I also... That or trial and error. I also remember that multiplication has to have like a certain amount of sets in it. I know where to find the information. And that's the important part. We were going over down in here somewhere. Right about here. Well, okay, I actually have 2 draw elements. It looks like I should only be having 1. And it looks like I should only be having... I should be going bing bong. And I should be going bing bong. And because now we're going GL draw arrays. Made a GL triangles. I'm imagining we need more than 3. 0.36, huh? Oh, it's more than... Hang on a second. I'm curious about it, but... So it's mode, count, then type. Or... I think the indices is the one that's optional. Curious about that. Anyways... Where are we? Here we are. That should be correct. Am I forgetting anything, guys? I don't think so. I'm trying to move quickly tonight because I want to get something done. I mean, not much anyway, but I want to just not leave you guys bored. So I'm worried with programming that you guys won't be as interested as me. Then we've got ourselves, so we have the arrays. I'm curious about what those... Hang on. And then 36 of the count.
Since we have 6 faces and 6 vertices per face.
Oh, that is true. I'm glad he explained that. That's where the 36 comes from.
Drawn vertices. Okay, and then in the vertex shader now, you can get rid of the color attribute again, update the location of the texture.
Vertex shader. Don't mind if I... Vertex core. That's the shader, yes. We can get rid of the color. I'm just going to comment it out. Comment-based version control can't be beat. Except by literally every other kind of version control, but we don't talk about those.
Texture coordinate to 1 because we updated the index.
Oh, hang on. We weren't done there. Vertex core is 1. I just pressed the number 2 again. Uh-huh.
We can keep the out
That's correct, isn't it? Yeah, it's correct.
of the texture coordinate, but remove the out of our color because we aren't passing it in.
Yeah.
You can also comment out the mouse transform because we don't care about that. So
You're right. We don't care about it. In fact, we care about it so little that I don't think I think I forgot to put it in to begin with.
it should just be, the GL position should just be a vector 4 of a pose and then 1.0.
Yes, it is.
Um,
Wait. I'm missing something.
And then delete the hour color setting too because we don't define that. And
Gel position. Transform times. Oh, it looks like he's removing the transform. Okay. Not a problem, not a problem.
then fragment color, you can just go ahead and leave everything as is because we only want to take care of the textures.
Yeah. Don't mind if I do. I love leaving things as is. Where's our fragment core? Here you are. That's the one we're leaving as is. And that makes sense. Are we sure? Hang on.
And then fragment color, you can just go ahead and leave everything as is because we only want to take care of the textures.
Okay. Shimon, please, I have no idea what to do in coding since last time I've even had anything related to do coding work that I've done was 5 to 6 years ago. I promise I'm not bored, Shimon. I'm just silly. If there's anything you want me to explain to you, I can do my best, right? I'm not exactly a teacher, but I do enjoy explaining things. I can definitely explain what's going on right now. I can explain vaguely why we're doing some of these things. Just if you have any questions at all, just ask and I'll do what I can to explain it. And if I can't, I have Google right in front of me. In fact, I don't have Google. I have DuckDuckGo because Google is kind of don't like it as much. But yes, any questions, I'm right here for you.
Right, so now if we run
Should
this,
be working.
I believe we should see something. That's right. Build errors, right? EBO, okay, yeah. And then also remember to delete all instances or all references to the EBO, so delete
Yeah.
buffers. Do
So basically,
the EBO as well.
oh wait, hang on. We need to make sure the VBO is deleted. Main.cpp. We need to. Let's see, where are we deleting our buffers? Should be around here somewhere. Somewhere in here, somewhere. Delete. Here we are. You thought you could get away from me. I don't have any questions. Good to know, Mizuki Kanho. Good to see you, by the way. Let me see. What am I forgetting? I don't think I'm forgetting anything. I think we can run it right now. It's too simple. I wish I could learn, but that usually takes time. I'm learning right now, Violet. That's why I have this tutorial up. In fact, this guy here, Michael Greco, I can copy this link. I'm just gonna put this in chat in case y'all want to check him out. Because this guy is the one I'm watching the tutorials of. Because I don't know, like, anything at all, ever. This guy knows a bunch of stuff. All the time, always. This camera should be over here. Here's how OpenGL works. You create buffers, then you create more buffers, then you bind the buffers, and you end up with a lot of buffers and maybe some triangles on the screen. You're so right, Page of Malice. But yeah, this guy's tutorial series is amazing. Everyone should use it. It is a bit long. I recommend double speed. He's a bit meandering at times, but it's about as good as any college course. So I'm seeing stuff, but is it the right stuff?
Right now we run it.
Big sip.
This is what we want.
Hang on. I want to hug you. You're so silly and adorable, Sharky. Let's see. Oh, there it is, yeah. We're changing the opacity of the American flag. Cute. Yeah, Sharky is Sharky is the cutest. The cutest. I'm wrapping up my controller again, hoping I don't need it. But yeah.
It probably is, to be honest. Yeah, that is what we want, because we're only looking at the front of the cube.
I love you too, Sharky. You're the best. Mm-hmm. Do 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 do. So I'm pretty sure that if I'm looking at these positions, my assumption is that the entire cube is there, but the other sides of it are invisible to us because we're looking at it straight on. So if we can just, you know, rotate it somewhat.
So yeah, and the reason why, if we had, you know, I'm gonna leave that for later. I'm just gonna write this.
Yeah.
So even though it looks exactly as it was before, we can change a couple things here. So let's try and say in the vertex score, say apose.xy, because we want to keep those the same, and then we'll say apose.z minus 10. So we'll subtract 10 from the z position, and that will move it further back. And it's small. How about just say 2?
Okay, we'll head over there. We'll follow along. Apose. Hang on. Dot xy. Apose. Right. Night ma'am, no rush on the squats. Did I miss some? Did I miss some squats? Because you had 50s. Oh, on these squats, not on the squats. Not the, like, old English. I'll get to those in just a second, Grace. Thank you. And I'll see you next time, huh? I got so concerned for a second that I had missed something. Z minus 2. Oh, that needs to have a comma, don't it? And then we can go boom. And now it's just gone. Hang on. Minus 0.1. Okay. Minus 0.5. Okay. I don't know if that's done anything.
Try doing +2. Trying everything here. Nope. Did I fuck something? Did I screw something up?
I'm wondering too. No more change just doesn't exist. That's okay.
Yeah, probably just 0.5 because of the... Yeah, okay. It didn't change anything, though. Okay, well, it wouldn't change anything, but... And the reason why is because we're only looking at that right now, so you can't really see anything.
Yeah.
Everything's still normalized to that.
I thought so too. I should do those squats before I forget, because my brain also doesn't exist. Right? So I'm gonna... I don't think I'm gonna bother switching to my... Whoops, that is the... Let int equal hello. Hang on a second. No! Don't do that! You can't do that for store defaults. You can't just set... I'm just about to do some squats for store default, because somebody redeemed some squats, so... It works in JavaScript. I'm sure it does. No, I'm actually certain it does. I've been working a lot in JavaScript recently, because I'm working on a web app, aside from my OpenGL project here. But you shouldn't make int hello world. That's that's so silly of you. Alright, it's just 25 spots. We'll be over fast. 1, 2, 3, 4, 5. JavaScript lets you redefine undefined. Who made that language and why? What was their goal? 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, and 25. Okay, this is my chair, by the way. You can't see it, but I can. It's also very good to have you here for the first time for Store Default. We're gonna... hang on. We're gonna reset our tracking mode to face only. because we don't really need the full body tracking when we're not doing squats. It's a bit wasteful. Anyways,
but we can actually change that by rotating it along one of the axes. So in main.cpp, let's go ahead and say map for the translation matrix. Let's rotate that 45 degrees along the x-axis, we'll say.
here we are. Main.cpp, up here. Here. Hang on. No, here. What? What did I do? Oh, I just left something in older. That's so silly. 45.0 now. Then, goodbye, world. You're so mean, Sharky. You're the most evil ever. Okay, then we can go like this. And now when I click this, it works perfectly first try. Darn it. What does he do next?
And we want to set that in the shader. So remember to activate the shader and then just set the transformation.
Oh, so I just literally did the opposite of what I should have done, which was leave it. I had it right the first time. That's still not it yet. I'm a little impatient if you can't
The
tell.
cool thing here is we don't need to reset it every frame because it's just set in the shader. So now in the vertex core, just say uniform map for transform. Transform, yes, transform, and then
Okay. Okay, I have that already.
in the GL position, do like what we did in two videos ago, where we just multiplied the vector by the transform matrix.
Good evil noise. I can't believe it. We have an evil on the loose. I know what to do about this. Yoink. No, Mizugi Kanho. We don't want to. We gotta contain this evil. You're in the evil timeout.
And now we should see something different.
Transform times. I knew that. At least in theory, I knew it. We don't need any of that. Miss. No need to us. Hang on, what's this? This is Oni J Giggle from channel Oni Jayu. How interesting. That's a nice emote. It's very well made. I like the outline. Very clean. I like to notice the emotes people put in chat. I'm sure the artists appreciate that as well. The artist on this one, isn't this? You will not succeed. I will escape. No, you will not. You could never. And then I click it. Interesting. So that has done not what I expected. I'm actually curious about... Okay, no, that doesn't... Okay.
Different. There you go. Okay. So you're gonna notice.
Oh, interesting. So now I'm doing something wrong, huh?
By the transform matrix.
And that's vertex core, huh?
Now we should see something. We did the vertex. So remember to activate the shader.
Alright, then it's probably in main.cpp.
Shader and then just set the transform matrix.
Hum. Oh, on this one, it's rotated in a completely different way, huh? I don't think that's it. No, it is not. Okay. Then... down here... we do shader dot activate there. Draw shapes. Hang on. I've done things in a weird order, I think.
So you can't really see it. It's, yeah, exactly.
We're gonna have to go all the way back.
Yeah, that is what we want. It looks right. So yeah, and no, yeah, that is right. I'm sorry, that is right. So yeah, and the reason why, if we had,
Let's see.
you know, I know. buffers. Yeah, that is what we want because we're only looking at the front of the cube.
You know what? This is gonna take too long. We're gonna look at the GitHub. And then this is episode 12. We're just gonna go view all branches. Darn. So hang on. I've forgotten where I go for this. GL, blah blah blah. Here. OpenGL. OpenGL tutorial. Episode 31. Let's see. History. There it is. That's what I wanted. Oh, looks like Sharky's gotten out of the pin, huh? How evil and dastardly. We're on episode 12 here. So we're gonna go 12. Then we're looking at main.cpp. They changed their screen stuff, but that won't matter. What did I tell you? You're too evil. Put those in. Change those. Some of this stuff they haven't gotten to yet. 36 there. Create transformation. Oh, am I missing the delete statement for that EVO? Hang on. No, I'm not. All right. Let's see. Because for them,
it looks exactly as. Yeah, okay. It didn't change anything though.
let's see if we can get it back to how it was before. Let's see if removing this puts it back to how it was before. It does not. Okay. So then we know we're good to leave that there. Okay. Which means that it's definitely in here. I just go and undo a couple of things. Okay, well, we know we want that gone. We know we want... Actually, we can just comment it out for now. Might want it back. So we activate the shader. Then we want to say GL draw arrays. GL triangles 0 and 36. Alright. And I haven't done it. That makes sense. I didn't expect it to. Passing in transform to the shader.4, that makes sense. So obviously we want, is that 45? Well, actually, hang on. Now I'm a little curious. Hang on. Okay. Huh. Very curious indeed. So what would make it do that? Something wrong with the texture, I would think. Alright. Or something wrong with the shader. put this back to a little while ago. Yeah, but not maybe that long ago. We probably definitely want it like that. Right? Actually, I think that this is perhaps a shader problem somehow. Shader dot vertex core dot GLSL. Oh, dot XY but not Z. There we are. And our second one is not there because I commented it out, didn't I? Didn't I? Didn't I? Okay. So now we've got it to there. Right? But we needed it rotated, don't we? We'll let it get to it.
Okay, well,
We're at this stage right now.
And the reason why is because we're only looking at the XY plane right now, so you can't really see anything since everything's still normalized to the XY plane.
Yeah.
Change that by rotating it along one of the axes. So in main.cpp, let's go ahead and say glm mat for the translation matrix. Let's rotate that 45 degrees along the x-axis.
Alright. 45 degrees along the x-axis. Is that not what I was doing, though? 45 degrees, x-axis. How curious.
Axis, we'll say. And then we want to set that in the shader.
Uh-huh.
So remember to activate the shader and then just set the transform matrix. And the cool thing here is we don't need to reset it every frame because it's just set in the shader. So now in the vertex core, just say uniform map for transform. I believe we called it transform. Yes, transform. And then in the GL position, do like what we did in two videos ago, where we just multiplied the vector by the transform matrix.
Okay. Am I not doing that? Why am I not doing that? Huh. How curious. Mine looks identical. Basically, anyway.
And now we should see something different. There you go, okay. So you're going to notice a couple things here, like why are we seeing two Obamas? I mean...
Huh. Huh. How odd. So now it's not doing the rotation. Right? Where our shader is correct, but our rotation is wrong. Does he have the same variable name? He does. Alright. That's shader texture. I don't think I need... No, I definitely do need the second one, don't I? Because there's still two textures. What if you were the evil one? I don't know how I missed that. I don't think that's possible. I think I'm actually secretly not evil. So, let's see. What if I said move it on that axis instead? What would you say? You would say nothing because you hate me. Alright. Then, what if I say rotate it like that, huh? And then I said, shaders are an absolute superpower once you learn them. Diablo 4 does some really clever shader effects. I'm really excited for that too. I'm saying something. Does that mean you love me? I don't understand, Chucky. I'm sorry. Okay. This is something, huh? Heh heh heh. I figured it out. Really interesting is that this top one is rendering on top of this side one. Or maybe this is... No, it's normal. Everything's normal. I just didn't understand at first. No, there it is again. This should be rendering before that one. You said you're saying nothing to me, so you hate me, to the computer. Oh, you're silly, Sharky. It's very cool and interesting that the order that it's choosing to render them. It makes it sort of like an optical illusion. Yeah. Wowie. I could watch that all day, huh? Alright, so, you guys, I figured out what the problem was. Alright, check this out. Yeah. So, this little thing here was named transform, but my variable is just trans. Like me. So, yeah, it's those silly little things, huh? And I can actually go back up here and make it proper again. Over here. I put that on there, but I kind of want it on the x-axis to follow along with El Tutorial. It didn't matter before because we weren't rotating it before. Where did I go? And I'm up here. Now we move on.
So remember to activate the shader and then just set the transform matrix. And the cool thing here is
Actually, I need to use the bathroom. So I'm very sorry, but I will have to be right back. I'm gonna run an ad just so there's no pre-roll for the next while. But I apologize for it because I hate ads as much as you do. Bye. I'm back. It's me. Your favorite, I'm sure. I know it's Sharky's favorite. Beep-a-doo-boo. Pow-pow-pow. Alright. Let's see. Pretty much right back into it. I gotta ping this. Oh, it's not something I need to... That was from Miso. Oh, but it's late.
We don't need to reset it every frame because it's just set in the shader. So now in the say uniform map for transform, I believe we call transform. Yes, transform, and then in the GL position, do like what we did.
You don't know that? You're correct. I'm always correct. Name one time I've ever been wrong, and you cannot.
In two videos ago, where we just multiplied.
It's never happened
ever. And now we should see something different. There you go. Okay. So you're gonna notice a couple things. Why are we seeing two Obamas? I mean, two Obamas.
It's because you're looking at exactly halfway rotated cube.
There's no real good way to do this. Maybe if I go into paint, 3D shapes.
Yep, we know what's happening.
Just in the middle, face. Is this? Well,
yep.
At the one at the top, however, I believe is.
Your mom. You're so chill.
So the reason why this is happening is because of something called depth testing, or you might have heard of this as the Z buffer. So essentially, OpenGL does if we enable something called the depth test, it will keep track of all the normalized Z positions in the screen space, and it will determine if a fragment should be rendered if its Z position is less than what is already there. So for example here, the Z position of this bottom face here would not be rendered if depth testing was enabled. So let's go ahead and do that by going to the where do I do
okay.
it? Go above or go near the top just before rendering. I would do it right underneath the callbacks, and what we're gonna say is GL enable GL underscore test. So
okay, good. I can do that. Meow. Shaders. Callback. Okay. No problem. Beam bomb. Now when I do this. Hang on.
So what this does is it just enables depth testing. So now OpenGL will automatically write to something called a depth buffer, or the Z buffer, as I said.
Yeah.
And it will keep track of the Z positions or the depth of each fragment. And it will start fragments if they're too far or if something's covering them. Now in the main loop, just like we clear the color buffer bit, which clears the buffer containing all the colors, we have to clear the depth buffer bit each frame as well. So just say in GL clear, we clear the color buffer bit, and then we bitwise or that with GL depth buffer bit.
Okay. Meow. And then when we're clearing our buffers, beetle beeple, beetle beeple, beepa beetle, beepa beep, beepa clear. It says bitwise or GL depth. I'm assuming it's the same.
So this will combine the two switches, telling OpenGL to clear both the color buffer and the depth buffer bit. So now if we run this, we should see something.
Yeah, no, if I run this, I should see something. Yeah. Okay, but we can also uncomment this and see the thing rotating. How neato burrito may that be? Oh, yeah. This is what it's all about. Meow. Wowie. I am so cool for having this happen. On the one hand, yes, I am just following a tutorial. On the other hand, look at this. I did this, and I understand why it works, mostly. And I can do the thing with the cube. Cube. Nice. I'm pretty happy with that outcome. And I can just comment that right back in. Beep 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 beep. I bet he's gonna rotate it. I bet he's gonna rotate it.
Like this is. Wait, no, that's not right. Like this is what you should be seeing, and you see how this is kind of an optical illusion because you could be thinking okay,
yeah.
side, but then also you see it's like that. Okay, that's what you're seeing essentially. This is the front.
Yep.
Something bottom, and then one of the sides.
Sure is.
We'll get into depth testing a bit further down the line.
Beepy.
Yeah, because we can harness it to do a lot more interesting stuff than just discard fragments.
Yep.
Okay, so that's
I'm sure.
And we have finally gotten into 3D, but now how do we make that look proper? Because what we were doing there is we were using something called an orthographic projection.
Orthographic projection.
That all light.
Wowie. I know they're about to explain, but I want pictures. Yeah, it's about what it sounds like. It sure orthos my graphic.
Parallel.
Mhm.
So essentially, you don't have any depth perception essentially. So there's, let me just find this link. There's a very good explanation on Learn OpenGL.
Yeah.
So this
I can hear his
is-
mouth.
This is orthographic, so you don't really have a sense of depth. And then in something called perspective projection, which we are going to implement, you actually get that sort of camera feel, or that feel that you are in a 3D space actually. Orthographic projection is used for text rendering and stuff like that, where you just want to render stuff straight on and not have it be tilted and appear to be tilted in any way. Okay.
Interesting.
So we're gonna look at a few concepts here. So just like we were doing previously in the transformation video, we were transforming a position, a vector position, using a transformation matrix, and we were only confined to the 2D, or rather to normalized device coordinates. Now, in our programs, we're not going to want to confine everything to just -1 to 1. That would just be completely impractical. So
Yeah, it would be.
what we're going to want to do actually is we're going to want to place objects in our world, but then we want to use certain matrices to actually transform those positions into normalized coordinates. So as a result, when we pass in, or the vertices that we pass in, will be rendered as normalized when in fact we are interpreting them on the CPU. So on our side, we're looking at them in our world space, or whatever you want to call it, but we're looking at them in non-normalized coordinates, where something could be at like 2020 or 1010, but we're looking at them in actual units. And then when we pass in matrices to we're going to do this in the vertex shader, because remember, in the vertex shader, it will only render stuff in normalized coordinates. So we then transform the world space into something called this clip space here, which is in normalized coordinates. So we're going to use 3 matrices: the model matrix, which transforms an object from stable space to world space. So for example, the cube right now it's centered around 0, 0, 0, which is very good for primitive type or something. And then let's say we wanted to have it at 10, 10, 10, we would simply translate the model matrix to 10, 10, 10 using the GLM methods. And the second matrix is the view matrix, which essentially makes it appear as if it's from the camera. So we have to pass in the camera matrix there, and then the view space we have here, which is looking like that, and then the projection matrix will essentially transform it to look more like it's coming from a camera. And then that gets you to, sorry, 1 sec. Just gotta drink some water.
I see.
And then we have clip space, which is normalized from -1 to 1 in all 3 directions, or all 3 dimensions. And this is what the fragment or the vertex shader receives, and then the vertex shader will then transform it to screen coordinates on the viewport. So this is abstracted here. This transformation right here is abstracted from us. And that's what we actually, well, it's pretty much abstracted, but we essentially set that in GL viewport. So when we say here GL viewport 00800, that's telling OpenGL what the viewport matrix should be, or the boundaries of the screen. Okay.
Okay.
So let's start doing this. So we're gonna have a couple of global variables here, just so we can access them in the input function. So we're gonna have a unsigned or const unsigned int screen width is equal to 800 and screen height is equal to 600.
Not a problem, not a problem. I can do those 2 things. I won't even have a little bit of trouble with them. Somewhere up here, probably. Right? Yeah, just after that. Unsigned int. There we go. Squeezed peas, lemonies.
We'll see what those come in, or what those how those will affect us later on.
Okay, fine. I'll throw in some floats as well. Beetle, 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 beetle.
Variables real quick just to keep consistency. So, or just don't make it const, just make it unsigned int, and then just say screen width in the create window. So just use the variable.
Doesn't need to be const. Fine by me. I didn't like it as a const anyway. What's this? Oh, that's not good. Darn. I'll fix that in a bit. Oh, where was I?
Keep consistency. So, or just don't make it const, just make it unsigned int, and then just say screen width in the create window. So just use the variables there. So screen width and screen height, and then in GL viewport use the same variables as well.
So there's screen width and screen height in create window. No problem. I see what they're doing.
So GLFW create window should now have the inputs as screen
Oh,
width,
that's
screen
no
height,
good.
in the title.
Be right back. This little sore decided to be a little pesky, so I had to
title and then null and null.
put a little
GeoViewport,
band-aid on
you
it.
have the inputs at 0, 0, then screen width and screen height. And then we also want to go to the definition of the frame buffer size callback and have the inputs as screen width, screen height, then the title and then null and null, and then
GeoViewport.
then GeoViewport, you have the inputs at 0, 0, then screen width and screen height. And then we also want to
Got
go to the
those.
definition of the frame buffer size callback and
Frame buffer size callback. 2.
just update the values of screen width and screen height to the new width and new height.
Gotcha. Bing bang bong. Squeezed peas, lemon
That
dandies.
will affect our projection matrix. Okay, so now let's go back into the main loop, and we're going to actually create these matrices now. So you can comment out the transformation matrix that we have right now. You can actually go ahead and delete that for now. And let's
Says delete transformation. Alright, buddy. If you insist. I don't know why that isn't labeled. That should be labeled.
you can actually go ahead and delete that for now. And let's just set our variables are x, y, and z. So x is equal to 0.0 float, y is equal to 0.0 float, and z is equal to 0.0 float, just for now.
Okay. So that's just before the while loop. Oh, almost forgotten.
Alright, so now we'll move on to the main loop, and I'm going to get rid of a lot of these comments here, just to reduce the clutter. Alright, so underneath
Fair enough.
draw the triangles, we're going to want to...
I probably should as well, huh? Yeah, I guess so. I can make them again another time. Yeah. These ones I'm going to keep, though, because I like to rotate things. And then...
want to set the, or create the transformation. It doesn't really matter where you do this. You can actually do this above. I think in the commit that I have, it does it below, but it doesn't matter too much. So create transfer, you should actually do this above activating the shader. Just so you can pass it in as the most updated one. So create transformation full screen. So we're going to have a GLM, mat for model is equal to GLM, mat for 1.0 float. So
okay.
one thing that we
So before shader, what? Before shader activate. Yeah, okay. I'll just do it right about here. What do you call it? Create transformation for screen. No problem. And then that was what? Mat 4? Yeah. Mat 4. No, mat 4. Silly me. So there's that.
we touched on last time, or in episode 10, or 9, I think, was the...
What's he saying?
So one thing that we touched on last time, or in episode 10, or 9, I think, was the idea of an identity matrix. So identity matrix
Yeah.
essentially do nothing to the input. So if you multiply this matrix by a vector, it will not change the vector at all. And this is how all matrices are initialized as, or at least all transformation matrices are. Because you want to start
Yeah.
with just a plain transformation that does nothing.
I remember that
You
episode.
want to transform that matrix to do more based off the identity transformation. So then we're going to have GLM mat4 view, GLM mat4 1.0 float. So this is the view matrix.
We will copy, and we will paste, and we will say this one is now view. Then,
So once again, the model is for the objects going from local space to world space. So it's specific to each
from
model.
here to here.
The view matrix will be specific to each camera, and then the projection matrix will just be a general thing. Will be specific to each viewport. And then GLM mat4 projection is equal to GLM mat4 1.0 float. So initialize all of them as identities. Now we want to actually do some stuff here. So in
Okay. So we just get one more. That's projection. Then he wants to do something.
for model, let's create a rotation here. So model is equal to GLM rotate the model matrix by float GLFW get time times GLM radians negative 4.0 float, and then we will rotate it along the GLM vector 3 0.5 float axis. So
Okay. So what I'm seeing here is that I can copy that. Yoink. Go with model. Then this is actually time. Times the radians of 55 F. And that's a float. Of get time. This is a negative. And vector 3 of 0.5 F. Coolio Gulio.
0 axis, going through 0.5, 0.5, 0.5, and connecting to the origin. So that's just our rotation. And now we want to also, for the view, now what we're going to do is, we're going to say view is equal to GLM translates view, GLM vec 3, x, y, and z. So this is also the position of the camera for now. So we're going to be looking at...
Okay. So we say view equals GLM translate view vector 3 then x, y, and z. That's our camera position.
a very primitive camera, but essentially this just translates it to 0, 0, 0, so it does nothing, but it's just necessary to have there for the future. So we're just essentially translating where the point of view is to x, y, z.
Okay.
And then finally the projection matrix. So this GLM also has a function here, so we're going to say perspective, because we want to use the perspective matrix, not the orthographic.
Okay.
Here. So the frame of view, this is just essentially the angle, the measure in degrees or in radians rather, of how wide, or the field of view. So GLM radians, and we'll say 45.0 float. We can change this.
Okay. So we will go perspective. Wait, no, projection equals GLM perspective, and then he put radians, eh? Boom, radian, and said 45.0, didn't he?
In the future. Now the next is the aspect ratio, so this is just the float of the screen width divided by the float.
Excuse me. Float of screeny widthy widthy divided by float wait, hang on, how's he doing it? Okay. I don't know why I did it 2 different ways. I'm just a little silly. It's not a function. You're not running the function float on these values. You're casting them to a float. Yes. That is incorrect.
Of screen height, and now you know why it's so necessary to actually change these values in the frame buffer size callback.
Mm-hmm.
And then the far and near essentially just denotes the boundaries, the depth values on the results of the view matrix, of which this will display. So for us, we're going to say 0.1 float and 100.0 float. So if after
0.1 and 100.2. That's correct. Oh, of course it is.
transformations of the model and the view matrix, the projection matrix will essentially keep all values that are in between 0.1 and 100 in terms of the z coordinates or the depth, and it will then it will essentially make the rest of the values out of the normalized coordinates. So it'll say like 2.0 or -2 or -3, just something that OpenGL will not actually render.
Mm-hmm.
All right, and now we want to set these. So after shader.activate, just say shader.set mat4 model, and we're going to set these in the vertex shader in a second. Shader.set.
Okay, so that's going to be just that. Not a problem, not a problem. After shader.activate, we go set mat4 model, and we'll set it to model. Set mat4, and we'll call it view, and we'll set it to view. And then we have projection. No, hang on. Shader. Set mat4. Projection. Project. Bing, bing, bong.
Set mat4 view, and shader.set mat4
Yeah.
Projection.
Yeah. It was fast for him because he's at double speed.
Is my hair falling out? What the?
I don't know. Is it?
All right, we're just
Come on, but.
All right. So now that we have set these, we want to go back to the vertex shader to actually apply these
Yes, indeed we do.
transformations. So in the vertex core, let's go ahead and add the uniform variable. So you can get rid of the uniform mat4 for transform, and just say the model, view, and projection. So mat.
Yep. I don't actually know what my shortcut is for duplicating a line. I should find out. Help, tools, edit, options. Keyboard. Duplicate selection. Shortcut. Oh, hang on. We don't have one. If we just do Control D. Delete selected elements, that makes sense. What about Control Shift D? Okay. We probably won't need this one. Right? So now when I go, and I say, there we go. Now we have a bit of a shortcut. So we'll say, model, view, and projection. No amateurjections in here. Only projections. We don't need those comments. Those comments are doing nothing for anybody. Except to say that they are set in code.
Map for model, map for view, and map for projection.
Mm-hmm.
And all we're gonna do
I
now
hope
is we're
that's
gonna
not
translate
important.
each of the
Oh,
matrices,
that's
or each
still
of the vector by the matrices. Now you have to be very careful. Here, let me actually write this in OneNote real quick because this is an important point that we
Yeah?
need for later. Matrix multiplication. Give me 2 seconds to plug this in.
Uh-huh. Beep-bop, 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 boop. Beep-bop, beep-bop,
Are we all good?
beep-bop, beep-bop, boop.
Looks like alright. And go. And from the world to
Local to model.
world to view to and then to clip. So view and then to clip.
World to
So
clip.
view and then projection. So I sometimes like to call this the MVP model, or not model, just transformation.
Model view projection.
So we have our input here, and let's say it's our just pose, and then it gets transformed.
Yeah.
Now the thing with matrix multiplication is, and specifically with linear transformations, is the one that you want, the matrix that you want to multiply by first, or would logically multiply by first, goes in the back. So this is also seen in the order of multiplication with just the transformation. So we have transformation.
Yeah.
Times the position. Now the order is very important because matrices can only be multiplied if the dimensions are very specific. So in an m by n matrix that has m rows and n columns, you can only multiply the two if the number of columns in the left matrix is equal to the number of rows in the right matrix. And vectors can be thought of as column matrices, where it's just, so the transformation matrix is some 4x4 matrix. That's what the mat4 means. So we have something like that.
Yes.
And like
Very
that.
true.
And we have our position matrix, which looks like this. So the 4 and the 4 have to match up, and then the resultant is the transformed of the output, which has the number of rows of the left matrix and the number of columns of the right matrix. So it's still 4 by 1. So like that. Now, the order here, or the reason why I kind of showed you this, was because the order is, you might expect it to be, okay, why can't the position times transformation? Now, but because it's the right side, the position is on the right, and we want to put the model first, we do the rest of the transformation times the model times the position. And this expands to the projection times the view times the model times the position. So essentially, the model is multiplied last in the transformation, in the total transformation matrix, and then the position goes on the right. So that's just how I'll do a little quick explanation on matrix multiplication.
First in, last out.
And then that's also going to be important when we want to look at what do you do for scaling, transformation, or translation, or rotation. And I believe it's you scale first, then rotate, then translate. So the model, or the yeah, I think. Yeah, that's right. So then you would, the way you would do that is the scaling matrix goes on the right, then it's the rotation, and then the translation matrix on the left. I might get fact checked there, but yeah. So that's just, this is going to come up later on. Just order of multiplication. So in our vertex shader, the transformation matrix in total is going to look like projection, times
view, model. Okay. No problem, no problem. Done and done.
So remember, projections on left, then view, then model. Now if we were to run this, we would be okay, and something would happen, and it would look a lot better. Okay, so we are inside the cube, and it's rotating, but it looks a little...
I want to be inside the cube. Let me be inside the cube. Yeah. In the Obama cube. And you know what? We can still change the opacity on that flag. Obama cube. Wow. Quite the fun thing. But you know, if we wanted to be outside the cube, you know what I thinks? I think it'd be as easy as, let's see, where's our X, Y, and Z? We made our Z like 5. How's that gonna change it? Okay, now we see nothing. 1. You know what, maybe we're going past the cube. Maybe we need -1. There we go. -3, perhaps? We've got ourselves a cube, everybody. Wee-oo. I was not only correct, I was also right, and...
Looks a little cleaner.
I was correct accurate, equitable, exact, factual, legitimate, and left. Precise, proper, true, right, actual, dead on, just, on the button, on the money, undistorted, unmistaken, veracious. Ooh. I like that one.
Voracious.
I love that voice as well. That's very much a late 90s computer game voice. Hang on. Let's fact check that. I'm voracious. Rower. Let's see. 9 minutes? That's too long. I do like this, though. Android plug-in play. Interesting. Okay. 2048 megabytes. Pretty nice. Anyhow, we're off topic here.
Cleaner now. It does look a little cleaner, and let's try backing up now. So let's set the view z equal to 3.0.
Oh, he's gonna go past it.
Or now you'll see how this works actually, because negative. I forgot to say one thing. It's the x, y, z, actually have to invert it. So negate it. So negative x, negative y, negative z. It's just how the coordinate space has to be transformed, so that forward is positive. I believe that's how that works. But yeah, we just have to negate the components. So now you see. Okay, so that looks a lot.
Well, he wants to just go the other way. He decided to make these all negative. I think that's silly. But we can still do it that way. Wow. And we can still do the thing with the thing. How cool. Some programmer in the 80s or something, well, not 80s, OpenGL, hang on. Cosmo 3D. Hang on. Now I'm interested. Describe the objects in the world in a data structure known as a scene graph. Okay. Interesting. Inventor and performers. Cosmo 3D system. Standardized high performance scene graph that's on top of OpenGL. Interesting. GL++. OpenGL. Hang on. I didn't say plus plus. There we go. Initial release is in 1992. So it would not be true to say. Oh, what? I like this. Where is OpenGL over here? OpenGL commands and shader GS isolation control. Quite cool. The screen's all the way down here. Very true. I like that display. It's a very nice one. Over here, we don't need that open anymore. I'm probably going to regret closing it.
That you would see if it was wrote. So if you saw a cube with Obama eating ice cream on it, and the American flag, it would look a lot more like that and less like this. This is in Paint.3 or in Paint 3D. You're looking at an orthographic transform or orthographic projection because it just wants to paint stuff like so. Like it doesn't want to do any weird shit. It's just painting whatever on a canvas that goes from 0 or 0 0 to whatever width and whatever height. It doesn't want to have shit in there or like any kind of cones of view or anything. But yeah.
People.
Now let's go ahead and play with this a bit. So let's try looking at the field of view and let's increase it to 90. So now that we are getting more in the view, something that is...
Increase it to 90, you say? Hang on, I probably did the wrong one there, didn't I?
The field of view, let's increase it to 90.
Yeah, that's projection I need to have. Maybe I'm doing 91. Just to one up it. We get more in our view.
So now that we are getting more in the view, something that is like that will get smaller. So because the field of view is kind of opened up, everything's going to be relatively
Yeah.
small. Now, if I decrease the field of view to, let's say, 30, it's going to be larger. You know, in Optifine in Minecraft, when you press C, it like zooms in. That just decreases your field of view. And we're actually going to look at that with the camera on the scrolling. So when we scroll the mouse, it'll actually increase or decrease the field of view. Yeah. Okay. So let's play around with the camera here and make something of a primitive camera rather. So in process input, let's take.
Yeah.
You can leave the. You know what? Should I whip out my joystick? I'll whip out my joystick actually. So
I'm not gonna do all that. At least not right now. I think we've made good progress today. We've been up for 2 hours. That's not bad. We can watch this Obama Cube for a bit longer. You know what? He's wanting to do it with that, but I want to do it with my scroll wheel. So where do I... Let's see. I'm gonna comment out the inputs there. Then, let's see. It wouldn't be keyboard, would it? It'd be mouse. Yeah, scroll DX. Alright. And change button went up and went down. Alright. Maybe we look at mouse.cpp. Alright. So yeah. Mouse.h then. We want get scroll DX and get scroll. Alright. Scroll DX greater than 0, I think. Then we should say we want this number here to change, right? So we're probably gonna need a new variable. I'll just set it here. Right? No reason not to, I suppose. FOV equals 90 by default. Hang on. We'll just set it over here. Like so. I'm curious to see if this works, what I'm trying to do here. Greater than 0. Let's say FOV plus equals 1. And then over here, we say, instead of radians, we say FOV. Does that work? Sure doesn't seem to have worked, huh? Alright. Scroll DX. You know what? Maybe I need to make it like that. Darn. Alright. Well, I guess we will just see what they do.
Okay, let me go grab
but we'll just do it with the mouse instead. Because I don't want to use the joystick. I wrapped up my controller twice already, and it's a long
it. So
cord.
essentially, we'll just be creating this so that you can just control it using the joystick and the buttons here to go up and down. So we'll say this. So we already have the axes here that we got last time in video 11.
Yeah.
With just the stick moving. So let's look at this here. So you can actually delete the mouse transform the global variable. It's not necessary anymore. And then you can do the same thing with the mouse, by the way. Just saying. But I'm just gonna do it with the joystick. You can use the keyboard.
Was I using a mouse transform? No. Do I even have a mouse transform? That's also no. No idea what he's on about. Clearly not relevant to me.
Do the same thing here. So I'm gonna say here if the value of the x-axis is greater than 0.5, so for the dead zone, we'll
Here, you know what we'll do? We will just simply see. We'll just have FOV plus equal 0.00. And it'll just do that like every frame. So then we'll see if it actually works or not. Do what we're trying to do. Maybe it needs a bit faster than that. I'm having a hard time telling if it's actually moving away or not. Oh, it definitely is. Okay, so yeah. We definitely did want to be setting it as a variable and doing what we're doing. Hehehe. Goodbye, Obama. And we can still change it. Wee, wee, wee. Oh. How interesting. It comes back. I didn't expect that. When it gets too far away, the values wrap around. I wonder if it'll start going the other way once it hits me. Wag. It does. Wow. Then I wonder, I set a number to be 100 earlier. If I set this to be 50 instead, I wonder if it'll come back sooner. Like, I'm wondering if it's fading out faster that time. I think so. It'll be much more obvious if we set it to like 10, right? What do you think? Is that faster? Doesn't seem a whole lot faster. Huh. If I set it back to 100 again, is that slower now? No. Okay, so that's not what's doing it. Wonder if we set this to be 5. Does that make it? What changes? It's hard to tell if anything's changing at all. But, yeah. We basically do need to be changing that, but we need to do it with the mouse. Right? Maybe it's just that we were using DX instead of DY and we don't have a other thing. Alright, so if I say mouse get scroll DY greater than 0. Let's try that. Oh. Hang on. I'm cool. I'm brilliant. I'm astounding. Maybe I need to make it at an increment of like 5 or something. Then we do the exact same thing. But flip that around. Oh, hang on. It's because that needs to be minus equals. Oh, it does not like subtracting, huh? But why? Maybe I just... Maybe I just say plus equals -5. Does that work at all? Does not. How curious. It only seems to like the positive scroll. I wonder what that will do. Nothing. Okay. If I set this one to be negative, that also doesn't work. Alright. So it's just that negative does not mean anything. There's something about the projection that means that, I mean, I get that it becomes negative if you just cycle through it all the way. I'm curious as to why. I wonder if he's about to tell
x,
us.
the global variable, plus equals lx. And we'll say divided by 5.0 float. And then same thing for the y-axis, so y plus equals ly divided by 5.0 float. And let's do this again.
Interesting.
Okay, so I'm moving side to side, and so it's like that. And you might so another explanation for the negation of the components. So when we did this last time, and we did mouse transform, we transformed it by the positive values, and that was transforming just the object in the screen space. So now that we are transforming the camera, we have to kind of do the objects relative to the camera, essentially. So it's just the opposite way. So if the object is moving positive 0.5 in the world, and the camera is static, essentially the object is moving negative 0.5.
I will think about all that another time. My brain's all brained out. We're gonna end stream. I hope y'all had fun. I think it'd be interesting if we tried to check on some other people. I don't know any of these people. If you guys see anyone you recognize, let me know so I can raid them. You know? And neural network is fun. There's also a fallen doll. Perhaps we just go to them. Oh, they're playing Game Boy. I wonder if they're using the GBDK. Probably, right? It's like the way to do it, you know? Reverse engineering a 3D printer is also cool. I think we go into them, though. Yeah. Alright, thanks everyone for watching. I had fun. I hope y'all did too. It was at least good progress for me. I know it's not the most interesting thing to watch me watch a tutorial and mutter to myself about nonsensical things, but it was nice. See you guys next time, and goodbye.